I turn off comments on my videos because one time somebody wrote on it as a comment, that's 15 minutes of my life I'm never going to get back. And I'm like, nobody made you watch the video. If you just close the browser if you don't want to watch my video. Anyway, uh, yeah, I'm like, you hurt my feelings. I'm going to turn off comments forever. All right. Uh, we are just chugging along, just so you have the big overview. Today we're doing 1.3 notes, and I think also 1.4 notes. And then Friday we're doing 1.5 notes, and that's all the notes for Unit 1. And then Monday we review, and next Wednesday we have a quiz. So that's our plan. All right, so here we are, expressions and assignments. So in Java we have the normal mathematical functions. Times we use the star, the shift 8. Division we use the slash that's by the question mark. And then we have plus and minus that are totally normal. And you can add parentheses if you want to change the order of things, or control what happens first. So for example, if you have 5 times 2 plus 3, that's 13. And if you have 5 times and then parentheses 2 plus 3, it does what's in the parentheses first, right? I mean, this is math, math. Now, here's something that isn't as obvious, something called integer math. In Java, when you divide 2 integers, the answer will also be an integer, and it just throws away any decimal portion. So here's a couple examples. 5 divided by 2 is not 2.5. It's just 2. It's not 2.0. It's just 2. Yeah.
So it rounds down.
It doesn't round. It's not rounding. In that case, it is rounding down, but it's really not ever rounding. It's just literally lopping it off. So it would change 2.9 to 2. So it's not going to follow the rules of rounding. Normally in math, if you had 2.8, we'd round it, and you were told to round it, you'd round it to 3. But this is just lopping it off. Yeah, just chopping it off. So 100 divided by 19 is 5. Normally it would be 5 point something. And 7 divided by 14, here's a kicker, is 0. It's not a half. You think, oh, that's 0.5. But you've got to remember, we're working with integers, and we have doubles. Double variables are decimals. But when you're working with integers, there's no decimals. You can't create a decimal. It just keeps it integer. So let's look at, could I have somebody raise their hand? Don't blurt it out. Raise your hand and say what you think 50 divided by 43 is. Caleb.
1.
Yeah, 1. Exactly. Somebody else, 22 divided by 5? 3 divided by 10? 0. Yeah, you want to say 0.3? I know you do. Anyway, it's actually easy once you learn it. And it, as I said up here, it's not rounding anything. It's just chopping off the decimals. I think people mostly make a mistake when it would be 0, and they're like, oh yeah, 0.5 or something. And then, okay, now if we're using a double variable, so I'll be really clear. If any of the numbers or variables in the expression is a double, then the answer will be a double. So you could have 15 integers multiplied together, and the 16th thing could be a double. The answer will be a double. So here's an example. 5 divided by 2.0, that gives us 2.5. Just it's because the 2.0 is a double. So it's going to be a double answer. It won't throw away decimals. And 2.0 times 4 will be 8.0. I mean, there's not a big difference between 8 and 8.0, but sometimes it really matters. 8, and you can force an integer operation to become a double if you want, just by putting 1.0 times at the front. And 1.0 is a double. And so after that, everything in the problem will be a double. So 1.0 times 5 divided by 2 is not 2. Remember, 5 divided by 2, if it was just integers, it would be 2. But the 1.0 in front makes it a double. And then I guess I did a complicated one. 1.0 times 10 plus 2 plus 8 divided by 3 is that. That's 1.0. That's 20 divided by 3 is 6 repeating, I just thought of a problem I should put on here for you. So I'll see what happens on the next page. Okay, I have another example. I'm going to add, just thought of it. Not all caps. Let's do what do you think that is? It's not 2.5. Yeah, it's 2.0. Here's what's up. In the parentheses, we have two integers. And so that happens first. 5 divided by 2 is 2. It's not 2.5. So just because there's a 1.0 out there doesn't mean that every operation deep down in the parentheses is integers. I mean, is a double. So I will put the answer down, and you'll have it in the slide deck. So just, you got to be careful. Okay, next. This will be new for some of you. I think a lot of you have seen it. We did it in Python. If you were in my intro class last year, it's called modulo or modulus. It's the percentage sign, and what that operator does is it divides the first number by the second number, but it gives you the remainder only. It doesn't care about how many times the number goes in. It just cares about the remainder. So, for example, 11 mod 2, you could say 11 mod 2. So that's saying 11 divided by 2. So we all know it's 5 with a remainder of 1. So all you get back from modulo is the 1, though. It throws away the 5. You don't care about how many times it went in. We just care about what's left over. So 12 mod 2 is 0 because 2 goes into 12 evenly. And 17 mod 5 is 2 because, 15, 5 times 3 is 15, and there's a remainder of 2. And then the tricky one that you'll just have to memorize, although I can talk it out logically, 4 mod 5 is 4. And what that is 4 divided, 5 goes into 4 0 times, and there's a remainder of 4. That's what's going on. It doesn't go in at all, and there's 4 left over. So, a question. Somebody, yeah.
Wait, what is that symbol?
It's the percentage sign. It looks a little funky here, but it's just the percentage sign. Shift 5. Yeah. Called modulo or mod or modulus. Now we have the equal sign, which is called the assignment operator. So in an expression that has an equal sign, the thing on the right gets put into the thing on the left. So we already did this just a tiny bit last class. Int x equals 7. That's taking 7 and storing it in the variable called x. And then here's another example of a statement. X equals x plus 1. That changes x, replaces x with 1 more than what x was. So, questions? Okay, we're going to practice. So I have a Google form. So no, not a Google form. I have a REPL assignment that's called 1.3 practice, day 4. I'll post it right now. And you're going to be given some variables, and I'm asking you to give me different outputs. And then in a little bit, we'll do. So when you finish that REPL, you can go into the AP classroom, and there's another set of 5 or 6 multiple choice problems that we'll do. Before we do, we are going to do notes continued in a minute. So let me pause the video, the notes again. Okay, so now we're going to do something called compound operators. So this will be new for a lot of you, maybe even most of you. We didn't do this in Python if you were in my class last year. Here's an example, plus equals. What that means is take the variable that's on the left and add 2 to it. So here's an example. I set up a variable x. I say x equals 5. And this line all by itself, just x plus equals 2, that means take x and make it 2 bigger. It's the same as if I wrote x equals x plus 2, which I know is not a valid math equation. I mean, that's an equation that has no solution. But this isn't an equation. We're assigning a value to the thing on the left, remember? So when we say x equals x plus 2, that's just saying take x, add 2 to it, and replace x with that. So this is a shortcut. X plus equals 2. It just means add 2. And yep, we got all the other ones. We have minus equals, times equals, divide equal, and even modulo equal, which means divide the first number by the second number and replace the first number with the modulo, which is the remainder. It's crazy. So if I said b equals 5, b minus equals 3, I would print 2. 5 minus 3 is 2. And if I did, and then continuing, if I did b divide equals 2, I'd get a 1, right? Because 2 divided by 2 is 1. And then if I did b times equals 5, I would get 5. 1 times 5 is 5. And then if I did 5 modulo equals 4, I'd get 1, because 5 mod 4 is 1. And we've just replaced the 5 with the 1. Question?
So since there are two things that it's setting b equal to, like 5, and then, well, for the first example, 5 and then 2, to avoid a contradiction, it only takes into account the most recent?
Yeah, the most recent is, the live one. As you move downwards in code, it's whatever line you're on. Yeah, you could have a program at the top say, hey, this thing's 100, and then down here you divide it by 2. So then down below, everywhere from that divide by 2 point, it's going to be 50. Yeah, good question. Other questions? These could be a little spooky because you're like, what? But once you learn an operator with an equal sign, these are, what's the title of this thing? Compound operators. And you'll have this slide deck in just a minute. Okay, so finally there's a special operator, plus plus, and that just means add 1. So it's even shorter than saying plus equals 1. You just gonna say plus plus, and that just means add 1. So you gotta love programmers. So b plus plus just means add 1 to the variable b, and that's the same as saying b equals b plus 1, and it's also the same as saying b plus equals 1. But I think you'd agree saying plus plus is easier than typing plus equals 1. And I said finally, but there's also a minus minus. But there's not a times times and a divide divide or modulo modulo. So if you have if you want to add 1 to a variable, you can do, if the variable is called num, you num equals num plus 1, or you could say num plus plus, or you could say num plus equals 1. But you can't say num equals num plus plus. Don't do that. You would never put the plus plus in with an equal sign. You would just do it all by itself. And then I think lastly, we have the minus minus, which is just taking 1 off of something. Just little encodings that you'll get to practice shortly. So here's a problem that is that you'll have. I'll put it on the quiz next week. It'll be on our practice today. And this is where having some scratch paper is super helpful. I'm going to just, you don't have to get scratch paper out, but you can do this in your head. But my advice down the line is to do it with scratch paper. So we start with 5 plus plus, we're at 6. Divide equals 3, we're at 2. Plus equals 8, we're at 10. Divide equals 2, we're at 5. Minus minus, we're at 4. So I think the answer is 4. Matthew, you do too. So do you. Caleb. Hey, and I wrote down what it was along the way. So in case you had any questions, when you do the plus plus, you're at 6. Divide equals 3, you're at 2. Hey, August. Plus equals 8, you're at 10. Divide equals 2, you're at 5. And minus minus, you're at 4. And then let's just say I threw modulo equals 7 on there. You would 4 mod 7. Is that 3 or 4? Matthew? It's 4. 4 mod 7. When you're doing a modulo and the second number is bigger than the first, the answer is the first. It's going to just be easier if you just memorize that. Okay, so now I've got a Google form I want you to do. I think it has 15 problems. So take your time, because to get full credit, you have to get them all right. So if you get 13 out of 15, that's the score I'm going to give you. But you can do it as many times as you want. And you can do it after you get home. I won't enter the score until Friday morning. So for today, just to summarize what, well, I didn't say, we're going to do the Google form. And then finally, I'm giving you, I think it's 12 problems on the AP Classroom. It's called a progress check. There's progress check A and progress check B. And progress check A goes all the way through 1.4, everything we've talked about so far. And that, I'm considering this due Friday before class starts. And the Google form, I'll score Friday morning during first period. So just being clear about everything. So today, before you go, I'd really like you to have the 1.3 practice REPL turned in and get the 6 first multiple choice questions done. That's today in class. The Google form, you should do that next. It's good practice. You get immediate feedback. I mean, right after you click submit, it'll let you see your answers, and you go, oh shoot, I forgot that 15 divided by 30 is 0. Right, in integer math, that's how it works. And then, but you can run it as many times as you want. In fact, if you get a bunch wrong, maybe I try to give explanations, and then you could try it again later, like from home. I know you could write all the right answers down, like this one's this is this, and then not learn anything. But it's better if you actually learn it. Anyway, and then finally go to the AP Classroom and work on the progress check problems. And I'd recommend using scratch paper. Questions? All right, I'm gonna assign this and and I'm gonna stop the video. Good news, August, the whole thing's recorded.